Okay, so we're going to simplify logs using this thing called the change of base formula. Now, the change of base formula is incredibly important and incredibly easy. That's a good combination, right? Good answer. Okay, so I have these rules that we talked about before up in the corner. Those have been on our notes for the last 2 days, that same bit. And also the same rules that we've been doing with our expanding and condensing. The change of base property is usually used with your common log or your natural log. I usually use it with the common log. And if you were to look in a math book, this is what the change of base property would say. It would say if you have log base c of x, you can change it to any base of the number over any base of the base. Or if you used a common log, which is the one that I most often use, log base c of x is the same thing as log x divided by log c. Or if you used natural logs, you could use natural log of x over natural log of c. Now, if you have a calculator like one of these, or you use one of the ones that I loan out, today is very important for you. If you have a Casio, you could care less about today for the most part. What is the issue with the log button on my calculator? It doesn't allow you to change the base. It only calculates either base 10 or base e. Well, if I can change something to have base 10 or to have base e, then guess what? I can use my calculator. So this is how we take all of these crazy ones that you had to do without a calculator on a quiz a few days ago and make it so that we can use a calculator. Make sense? So when we evaluated it without a calculator, we had to set it equal to x or y, right? And then we would go, okay, 4 to the y equals 1024, right? And then we would have to guess from there, basically. And 1024 is kind of a big number. It's not one of the powers of 4 that I know off the top of my head. I know that 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. And after that, it's kind of out of my immediate knowledge, right? Anyone know what 4 to the fourth is?
5. 256.
256. What is 4 to the fifth? 1024. Okay, so there I got it. So what's my answer? Y equals 5. That's the exponent you have to put on. Now, without having to go there, let me show you how the change of base property works. I can take log base 4 of 1024 and I can call this log 1024 over log 4. So on my calculator, I would plug in log 1024, close my parentheses, divided by log 4, and guess what? There's my answer of 5. A lot easier, isn't it? Now, what if I, let me just show you this, but you can also do it with a natural log. You can call it natural log of 1024 over natural log of 4 and still get the same answer. So if I do natural log of 1024 and I divide it by natural log of 4, there's my 5 also. So you can use common log or natural log, doesn't matter. Okay? What about this one? If we had to evaluate this without a calculator, we would set it equal to y. So I have 4 to the y equals 32. And this is one of those crazy difficult ones where I have to say, okay, wait, 4 to the y, that's 2 squared to the y, and 32 is 2 to the what? 2, 4, 8, 16, 32, 2 to the 5th. And what would I do from there? 2y equals 5, divide by 2, and y equals 5 halves. That's how we've had to do it so far, right? Let's try change of base. How would I do this with change of base? Log 32 divided by log 4. So log 32, close my parentheses, divided by log 4, and I get 2.5. What if I want it as a fraction? Because Mrs. Franken likes fractions more so than decimals. Do you know how to do that on your calculator? You hit second and this little F arrow D thing that goes back and forth between a fraction and a decimal. So I go second, that, see the F arrow D, fraction to decimal, 2.5. Oh shoot, it's a mixed number. That's even worse. How do I get rid of the mixed number? Hit second and your fraction button, because do you see the mixed number? A, B over C to D over E. That's going to take a mixed number and change it to an improper fraction. There's my 5/2. Okay? Those are two things that you really need to be pretty fluent with on your calculator. They're very, very helpful to use. Okay? All right. This one. I don't want to evaluate this without a calculator. Because if I set that equal to y, I'm looking for 1/2 to the y equals 1,000. Well, I know it's going to be negative, right? Do you know it's going to be negative? Why? Because one's a fraction and one's not. It's going to be negative. But beyond that, a power of 2 to get to 1,000, it's going to be a big power of 2, isn't it? Because right on my hand, 2, 4, 8, 16, 32. I only get up to 32 on one hand. So let's just skip the without a calculator and let's go straight to the change of base. So I would plug in log of 1,000 divided by log of 1/2. Log of 1,000 divided by log of, I would recommend, I don't know, but I don't think my calculator is going to like, oh, it did okay. You can use your fraction button or your division button there. And there's the negative I was expecting, but it's negative 9.965. I'm going to call it 97. You okay with that? You'll have to read your directions to see if it says round to the nearest thousandth, hundredth, whatever, to get your decimals. Let's see what she has to say here. In our assignment, you are asked to solve without a calculator whenever possible, and you must show enough work to convince us that you understand the process. Meaning that if it says without a calculator, even if you use your calculator to check this, I need to see enough work that I know you know how to do it without a calculator as well. You can use the change of base property to confirm your answers if needed or to finish off the problem after you've simplified this process as far as possible. Now, one thing I want to mention, I'm going to go to the back here. So we just found that to change the base of something, like if I have log base 4 of 62, to change the base of that, I call this log 62 divided by log 4, correct? That is change of base. Now, the reason why I'm specifying this is especially because you have a quiz on this right now. But for some reason, as soon as I introduce this change of base thing, then all of a sudden people have issues with condensing. If I have something like this, log of, let's say I have a common log of that. No, hang on. Hang on, let me change that. Log 64 minus log x. This is the kind of thing that was on your homework, right? Where we condense. For some reason, as soon as people see this, they want to say that their answer here is that. Do you see why that's wrong? Because the whole point of condensing is to only have to write the word log once. So they get this whole fraction, oh, I'm just going to write it the way I know how to, and that ends up being the change of base. Do not get that confused. If you are condensing, you should only physically be writing the letters LOG once in your answer. So this would be 64 over x. Do you get what I'm saying there? Okay, I just want to make sure that you know that condensing you're going down to 1 log, change of base you're not necessarily going down to 1 log. Okay? All right, let's go through the end of this really quick. we had a formula here. Do you remember this one? This is one of the ones at the top that I gave you. Right there. So if I have log base b of b to the x, this was on your homework last night also. You want to think about it this way. You would bump x to the front. So you have x log base b of b. And what do we know about log base b of b? It equals 1. So if I have x times 1, I have what? X. Shortcut way of knowing that is I call this a matchy-matchy rule. Yes, that's the official name of it. If I have matchy-matchy with my base and my number, my answer is just the exponent. That's the shortcut way of getting there. Okay. This is another matchy-matchy. Matchy-matchy. Do you see that? My answer is x again. So if I have matchy-matchy, my answer is x. So. Ms. Armstrong says there's no name for these formulas, but remember, if you have an exponent that's a log and you got some matchy-matchy going on, your answer is x. And if you got some matchy-matchy there going on, your answer is x. So I call them the matchy-matchy rules. But you will never see those in any textbook, at least named that. So what would my answer here be? Matchy-matchy, my answer is 56. What about here? Trick question. There's no base, is there? Which means it's base 10, so it is matchy-matchy. Do you get that? So what's my answer? 2x squared y. What about here? Your answer would be x plus 7 because, again, doesn't look like it, but it is matchy-matchy. Okay? Let's see. Express as a single log. What does that mean if it says express as a single log? Condense. So these would condense to what? Multiplication, right? Log base 2 of 8 times 4 is what? What is log base 2 of 32? Can I use my change of base if I needed to? I would type in what? Log 32 divided by log 2. It's 5. So. She has it listed there again, so I'm not going to do it again. This one she has listed twice also, so I'm just going to do this one once. Those two have the same log, so I can condense them. It's addition, so what's it going to condense to? Multiplication, so that gives me log base 15 of what? What's 3 times 75? 225. Well, what's log base 15 of 225? How can I do that on my calculator? Log 225 divided by log 15. 2. So in other words, I'm saying that 15 to the second power equals 225. Okay. This one I don't think I want to get into today. I may save it for the next day. I may just skip it altogether. We'll see. Okay. But that gives you enough to be able to start using this change of base formula on your homework. Okay.